Welcome to another video of the graph series. Today we'll be again picking up a typical question of graphs. Now it is somewhat harder to think of it if you have never seen the question before. So we'll be developing the intuition for the new concept that is required for this question. But once you develop the intuition for this particular concept, you'll be able to do a lot of similar questions. So be sure to watch this video very carefully, because if you haven't done this question, then it might be harder for you to crack it in an interview, and it is a very common question. It is one of the most common questions in graphs, so you really have to understand it. Let's get started. Before we move ahead, I would just like to take a moment to remind you to be consistent and make sure you do not miss any videos in the graph series. So make sure you subscribe, hit the notification bell icon. You will also stay motivated, and you have no idea how much your support will mean to me. There's so much of free content available on the channel. There's HLD, LLD, DSA, Advanced C++, tutorials, mock interviews, and so much more. So if you think I deserve your support, please subscribe, hit the notification bell icon. And there's obviously a bunch of stuff that I cannot do on YouTube, like mock interviews, live interactive classes. So we have educourses.com. We have live courses, self-paced courses with live doubt solving support, which both of them we have mock interviews, and we have a lot planned in LLD, HLD, Advanced C++, DSA, and so much more. You have no idea. So if you want me to be part of your further learning journey process, please check it out. The link is in the description. And now let's continue. When you look at the question, it actually looks very easy, because we are given a node of a particular graph, and then we are given a few things. We are supposed to create a clone of it. What are the few things that are given, and what does a clone mean? So here they have tried to demonstrate it with a diagram. Here, first thing that is given to us is that it is a connected undirected graph. Now, why connected is a very important keyword, because it is in blue. Why is it so important? See, here we are given only one node. Because it is connected, that means it is possible to reach all the other nodes from this one node. If this connected was not given to us, then it is possible that there were a few nodes that were not reachable from this node. So how would you actually create a copy of those nodes, correct? Then you would need info of a node in the other components as well, right? Because you need to be able to reach all the nodes. Now, at least from any node, you should be able to reach there. Then one node would not have been sufficient, but because it is given that the graph is connected, you can reach all the nodes. So this one node is sufficient. Now for interviews, it might not be given. You might be expected to ask this question. So that is why these little points are very important. You need to understand what are connected and disconnected graphs. Now it is given, create a deep copy or clone of the graph. What does a deep copy mean? So here in the diagram you can see. Here you can see it is of different color. Why? Because it is of different memory, like a new memory is allocated. Even though value might be same, the value is same, the neighbors are same, but new memory is allocated for this. Basically, we are not referring to the same nodes. Here you can see it is yellow only because we are referring to the same nodes. Here we are referring to the new nodes. Also, this is also not correct because we have to have the same neighbors. The neighbors of one is like 2 and 4. Here also it is 2 and 4 versus here it is 3 and 4. So the connections should remain same, but you have to allocate new memory for the nodes. So that is the question given to us. Let's try to understand why is this even a hard or a typical question. So this is the example that is given to us. Let's see if it is easy or not. Let's begin from any node. So any one node could be given to us because all the other nodes are connected. So let's say we start from 1. So it is very easy. I just create a new node with the same value. Okay. Now I need to copy the neighbors. So I take all the neighbors one by one. I go to 2, I create a copy. Okay. Then I go to 4, I create a copy. Now for 2 also I need to copy all the neighbors. So I copy 3. Okay. For 4 also I need to copy neighbors. So should I copy 3 again? I've already copied 3. So yeah, obviously you will say, Keerti, we know it is graphs, so we need to mark them as visited. Okay. Okay, so let's do that. Let's mark them as visited. I do this. I create a copy of 1 and I mark it as visited. Okay, visited. Then I create a copy of 2, mark it as visited, and I connect these two. Then I create a copy of 4 and I connect 1 and 4. Then for 2, I create a copy of 3, visited, and done, and connected 2 and 3. Okay. Now for 4, I see there is a 3 connection. So I need to connect it to the new 3. But do you see the problem over here? It is already visited. I basically had a boolean. I said, okay, now this is visited. So I am not going to create a new node. But where is this new node? How do I connect? What was the new address that was assigned to it? I have no idea. Correct? Similarly, suppose these two were also connected. Then now I have to connect these also. But what is the new address where this 3 is present? Where is it? How do I know? Because I just marked it as Boolean, I went ahead. So now what we are going to do is we are going to keep a map. Basically, as I keep creating the new nodes correspondingly, like for 1, 2, 3, 4, like suppose for 1, I created 1 dash. So I'll keep it in the map. For 2, I create 2 dash and I keep it in the map. For 3, I create 3 dash and I keep it in the map. For 4, I keep it in the map. So now when I need to connect 4 to 3, what will happen is I can see in the map that, oh, this is what the node is. And now this 4 dash that I am creating, I need to connect it to the 3 dash. I hope you get my point. The point is that if I have only Boolean that, okay, this is visited, what is going to happen is when I need to connect the edge, I do not know that where my new node is. I need to have access to that new node. I nicely went ahead by just marking it as visited. I visited, okay, you created a new node, but how do I now access this new node, right? So for that, you will be able to get it from the map. That, okay, there is a new node that is created from 3 and it is 3 dash. So now from 4 dash, you connect 3 dash. So this is a very, very important point. A lot of people just directly jump that, okay, we are going to use a map. Why are we going to use a map? Why is just visited array not enough? Because over here, I also need access to that new node to be able to connect it. It is not like I just have to create 1, 2, 3, 4 and return. Okay? Maybe you created 1, 2, 3, 4 and you connected this. Now when it comes to 4 connecting to 3, I should know where the new node, like where is it, what is it. So I should be able to see it in the map that, okay, for the old 3, this is the new 3, this is the new 3 and I can connect it like this. So I need access to the new nodes that are connected. That is why I am using the map. Now it becomes very, very easy. Now the code is fairly easy. We just have to traverse through the map and keep creating the new nodes. So let's do that. So we all know we need an unordered map because we need a hash map. But now we know that we will be visiting all the nodes one by one and we are going to need the map again and again. So one thing that you could do is you could create a global map or you could make it outside. Or what we could do is we could create another function, utility function, where I'm going to create the map and I'm going to pass it. So I'm going to do the second approach. You can also create a map outside and then just use it in the same function. Starting with creating the hash map, an ordered map, and the map is from what? It is from node to node itself, right? So we are given the node. This is how the node looks like. This is the value, then the vector of neighbors. So it is from node to node itself. Node, it is not integer to integer because I need to attach what? I need to attach the node itself. So for this node, what is the new node? Node at the new node is also of the type node star only. But the only thing is it has new memory allocated to it. So I'm just calling it map. And how does it look like? It looks like this, that old and then we have new. So old node is the key, new node is the value basically. And now I'm going to call another function. I'm going to call it clone graph util, whatever you want to call it. I'm passing the node and the map. Note that I need to return the cloned node also. So obviously I need a return type also of the node star only. So my return type is basically node star and I'm calling it clone util. And again in C++ we have to pass everything as reference. Please do not make these mistakes and please try writing the code yourself so that you get used to writing the code and you do not make these mistakes. So this is the current node I am considering. The first thing that I need to do is create the new node corresponding to this node, right? So I am calling it new node and what am I going to do? New node, and I need to pass the same value. So in this node there is a value, correct? And that value I am going to pass. So here you can see there is a constructor. In the constructor, I am passing the value and I can get the value from this node. So I am just creating a new node with the same value. So I have created a new node, added the value. So the value is same. What else I have to connect? I have to connect the neighbors. For that, I have to go through all the neighbors of this node, correct? So what do I need to do? I need to iterate through all the neighbors of the node that we have passed. So what am I going to do? I am just going to write a for loop that for every neighbor where in this node ka neighbors. So in this node, I have neighbors as well, right? So in this node ka neighbors, I am going to go through each neighbor one by one. And the first thing that I have to do is see whether this neighbor is already cloned or not. How would it already be cloned? If it is there in the map, that means it is already cloned. If it is not there in the map, it is not cloned. I need to clone it. So the first thing that I need to do is find in the map. So map.find, and what am I finding? I am finding the neighbor. If the neighbor is not present, what am I going to get? I am going to get the end. So this means that it is not present. I need to create the neighbor ka clone, right? This means that it is already created. So now it is created, it is there in the map. Now what I need to do, I just need to map basically this new node that I have created in that neighbors list. I need to add it. So basically what am I going to do? New node also has neighbors, right? Currently it is empty. Here you can see in the constructor I just created a vector which was empty. Now in this new node, whatever are the neighbors, it is a vector, right? So in that I need to push back what? I need to push back in this map ka neighbor. So basically if you see, map of this neighbor is going to give me the cloned version of that neighbor. Now that cloned version is what I need to push back into this new node ka neighbors. So this should make things clearer. So I have new node ka neighbors. Initially when I created this new node, it would be empty. Now in that I need to keep adding the neighbors. I saw, is the neighbor already cloned? This means it is not cloned. Here it means that it is cloned, right? Because I'm in else, it is already cloned. So I already have the clone neighbor in map of neighbor. Okay, so this clone neighbor, I am adding it to this neighbors. Otherwise, what I am going to do is, in this new node ka neighbors, same thing I need to do. But now it is not there in the map, right? It is not there in the map. Now I need to iteratively clone this. Okay, so I need to iteratively clone this. So I am going to call the same function again. That is why this is recursive function. Now my new node will become the neighbor and the map is going to remain same. Why do I need to recursively call it? Because even this neighbor would have neighbors. We would have to check for that also, right? So if this neighbor has this neighbor, now this neighbor could have another neighbor. I need to check for that as well, right? So basically I am sort of doing DFS. I am recursively traversing till I am sure that I have traversed through the entire thing and I have cloned all the neighbors. One very basic question that I am hoping that you are also having right now. I hope you are thinking like that. If not, then pause and think that why did you not think of this? I am checking whether it is there in the map or not. I obviously need to also add it to the map, right? So when I create a new node, what do I need to do? I also need to add that whatever was the node, for that I have created this new node. Okay, and in this new node, I am adding the neighbors now. So here in these two lines, what am I doing? I am creating the new node, adding it to the map. In these lines, I am attaching the new neighbors for that new node. Now in this new node, some neighbors might already be cloned. So that is this case. If it is not cloned, I am iteratively calling for that neighbor as well. Now I just need to return this new node from here. Do you think this is going to work or not? Should we run it and see? At least think of the examples. Now in the example it is given to us that adjacency list is empty. Is it going to work or not? Let's try running it and see. What do you think? This is, okay, I have done one silly mistake. Give me 1 second. I am just pulling out the semicolon. Let's run it now and see. Okay, here you can see it is not working. What is the error? The error is member access within null pointer. See, this node that is passed to us could also have been null. That means it is an empty graph. There is nothing. So we need to put the check that if there is no node, basically if node is equal to null, I just need to return the node itself or the null itself. Okay, you can also return null like this or null PTR. But there is one more thing that you should be thinking. So I said that this node could have been null. So why am I putting check over here? Think about it. Is it enough to remove the check from here and just add over here? Because see, the first node that is given to us, that could be null. But after that, whenever I am calling the clone util, I am calling only for the neighbors. Neighbors cannot be null. So do I need to put this check or not? Think about this. Now you need to think of these cases. I am calling only for neighbors, right? And that will never be null. So this node will never be null. The first node that I am passed, that could be null. So can I run and submit it? Let's see. So it is about the small details. You need to start thinking why connected, why deep copy, why do I need a check over there and not here. So you need to think of the details. Let's get to the Java code now. So we have a node given to us. We know that we need a map. Now we know that we will be moving to every node one by one and we are going to need a map all the time, right? And we will need the same map, not like new map for every node. So there are two things. One, you can create a map outside and you could use that in the same function. You could recursively move to the other nodes, or you could create another function and create map inside this and pass it like a utility function or a recursive function where you're going to pass the map. So you could do otherwise also, you could create a map outside and use this function only as the recursive function because we are going to be traversing through it. So we are going to be using DFS. Here what I'm going to do is I'm going to create a map and then pass it to a new recursive function. So I'm going to create a hash map. Now think about this, the map is going to be what? It is going to be node to node, right? Because the old node to the new node. So what is the key? It is the old node. And what is the value? It is the new node. So the type is going to remain same. It is just that new memory is allocated to it. I'm going to call it map itself. And I'm going to call another function which will be a recursive function. I can call it anything. I'm going to call it 𝐶𝐞. And I'm going to pass this node and the map to it. And that's it. I could have created the map outside and used the same function. But I'm just doing it like this. And here it is basically old node mapping to the new node. So this is how it looks like. Now let's write the recursive function. It's going to be private 𝐶𝐞. I have passed the node. So this is the current node that is in consideration and the hash map. So the first thing that I need to do is create the new node, right? So I'm calling it new node. But what is the value that is going to be in this new node? See, this is the node that is given to us. It has a value and it has some neighbors. So the new node that I'm going to create, that is going to look exactly the same. So the value should be same. So whatever in this node, whatever the value was there, I have created a new node with the same value. So basically this is the constructor that I'm calling. So I have basically attached the same value and I have created the neighbors, but the list is empty. So now I need to start attaching the neighbors. How do I start attaching the neighbors? I need to go through all the neighbors of this node and see that, okay, is that neighbor already cloned or not? If it is cloned, I just need to attach it to the new node. Otherwise, I need to clone that neighbor and then attach it to the new node. What is the first thing that I need to do? I need to go through all the neighbors of this node that was given to us. So how do I do that? I write a simple for loop that for every neighbor of this node ka neighbors. So node has this neighbors, right? So I'm going to go through all the node ka neighbors. And first thing that I need to check is that is it already cloned or not. So how can I check that? That in the map, does it already contain this particular neighbor? So if map contains this key neighbor, that means that it is already cloned. So if not, that means it is not cloned. That means I need to create a new one. Otherwise, it is already cloned. When it is already cloned, I just need to attach the cloned neighbor to this neighbors. So basically, okay, very simple. New node has no neighbors right now, okay. So since it is already cloned, what am I going to do? This node ka neighbor, basically this neighbor is already cloned. Now this new node doesn't have any neighbor, I need to attach it. So in this new node ka neighbors, this neighbors list is there. Currently it is empty, right? So currently it is empty. In this I need to add, and what do I need to add? The cloned version of this. How do I get the cloned version on this? Map.get and this. See, how is this happening? This is the neighbor of this, correct? Node.neighbors. So this is giving me the cloned neighbor, the value, right? Once I get that, I am adding it where? I am adding it to the new node ka neighbors. That's it. Versus over here, I need to again add it, but it is not cloned. So I cannot do map.get because it is not there. It does not contain it. So instead of doing map.get, what am I going to do? Recursively, I am going to clone this new neighbor now. And how are we going to do? In this clone util, what is my new node? My new node is this neighbor now. I push it over here and then map. And that's it. Repeating it again. So new node ka neighbors is empty. We need to add the cloned neighbor. But there are two conditions. It might already be cloned, it might not be cloned, this neighbor. If it is not cloned, then I am recursively calling it. See, 1 ka neighbor might be 2, 2 ka neighbor might be 3. Now for this 2 also, you need to clone all the neighbors, right? 3, 4, 5, you need to go through all the neighbors. Because you're doing DFS, you're traversing through all the neighbors. That is why it is given, it is connected. You need to check the neighbors of this cloned neighbor as well. Correct? So you're recursively calling it again and again. Now one thing that you should already be thinking of, and let me know if you did not think of it, pause and think, what else is left to do? We are almost done with the code, but think about it. We are checking whether the map contains this neighbor or not. Where are we adding into the map? If we are obviously checking, we obviously also need to add as we are creating the new nodes, correct? So as soon as I create this new node, what am I going to do? Before going to the neighbors only I can do it. That in this map, what am I going to do? I am going to put node and in that I will put the new node. Why before this? Can I put it after this also? Think about it in the comments and let me know. And I'm going to return this new node. Okay, what else is left to do? Here if you see, I'm supposed to return node. So I have not written any return statements. Here also I'm supposed to return it. Let's run it and see whether this works or not. Think of all the examples that are given to us. Have we taken care of all the edge cases or not? So let's see this map. Okay, I have not done new. So new hash map. That's what happens when you write both C++ and Java code parallelly. Okay, so here we can see that the value is null. So here the value that is passed to us can also be null. Now the interesting question is that this value null check, should I put it in this function or should I put it in this function? If I just put that if node is equal to null, return null, is this enough or do I need to check above also? What do you think? Let's run it and see. Am I passing all the test cases? Think about it. So why was putting it over here enough? Why not put it in the helper function? Because only the node that is passed to us can be null. After that, whenever I am calling the 𝐶𝐞 function, I am calling only for the neighbors and neighbors will not be null. If neighbor would have been null, we could have either added the check over here before calling the 𝐶𝐞 or we could have added the check after inside this. So note these basics of recursion. Before calling the function or after calling the function, you could have added the check, but here we do not need that. Only the node that is initially given to us could be null, but otherwise it will work fine. So yes, we passed all the test cases and I hope you're really liking the series. It is taking a lot of effort and I hope it is worth it. Please do share it with your friends also and please do show up next time. Please do subscribe and hit the notification bell icon. You have no idea how much it will mean to me. Check out edu courses, the link is in the description. See you next time.